Now that we've looked at how to turn a 0-1 equation problem into a Hamiltonian cycle problem with edge pairs, we're going to look at how to turn that into just a Hamiltonian cycle problem. We're going to put that on hold for a moment though, because I think it's also useful to give an example where my original equation doesn't have a solution, and then show that the corresponding Hamiltonian cycle problem also doesn't have a solution. So to do that, I'm going to take my equation, and I'm going to do the same construction that I did in the last video, where I'm going to go ahead and take these blue, it doesn't need to be blue, but I'm going to make them blue. I'm going to have these blue pairs of edges here representing my variables. I still only have two variables just because more than two variables, this graph starts looking even messier. And then we'll have oh, I did the wrong thing up there. We'll fix that. That's supposed to be a equals 1. And then we have these pairs of edges over here that represent each row of my matrix. So I'll have one edge representing the fact that I have an A in the first column and a 1 in the A column and a 0 in the B column. And then I'll have an edge here representing that I have a a 1 in the B column, a 0 in the A column. And then I'll have this pair here representing that I have a and a 1 in both columns, in both the A and the B column. And then we'll go ahead and connect these all up. So that's going to give me my graph, and then I need to talk about my edge pairs. What are my edge pairs? Well, I need to line up, let's number these edges. I know that I need to line up the edge representing A equals 0. That needs to line up with all the edges over here labeled A. And then I also need to line up everything where B equals 0 with the edges labeled B over here. So that's going to be 3, 6, and 3, 7. And we want to show that there's no Hamiltonian cycle. And to do that, let's just do a little bit of case analysis. Well, first of all, let's convince ourselves that there's not a solution over here. The reason why there's not a solution is because I definitely need A to equal 1 in order for this first column to have a sum of 1. And then I need B to equal 1 for this second column to have a sum equals 1. But if that's both true, then my third column, sorry, I said column when I meant row. I need A to equal 1 for my first row to equal 1. I need B to equal 1 for my second row to equal 1. And then for my third row, I get 1 plus 1 equals 2. I have two 1s in that row instead of just 1. So that's a problem. And in essence, we'll run into the exact same problem here. If I have a Hamiltonian cycle, I'm going to need to use this edge 8. So in this edge pair, I'm definitely going to need to use that, and I'm not going to be able to use the edge 1. And since I'm not using the edge 1, I definitely need to use the edge 5. Similarly, when I get down here, I need to use the edge 7. So I'm not going to be able to use the edge 3. And since I'm not using the edge 3, I'm definitely going to need to use 6. But then, let's go ahead and take a look at that. So we're saying that we're setting A equal to 1. Then we're setting B equal to 1. And then we run into a case where I'm forced to use, well, actually, let's go back a little bit because I said A equals 1 and B equals 1. But I really should have said, I can't use edge 1, so I have to use edge 2. And then I can't use edge 3, so I have to use edge 4. And then we also said that I need to use both edge 5 and 6, but that does a loop-de-loop, and that's a problem. And again, we basically logicked our way through why we needed to use, or why I couldn't use edge 1 and I couldn't use edge 3. It's because I had to use edge 8 and I had to use edge 7. But when I did that, that also meant that I had to use both edges 5 and 6, but I'm only allowed to use one of those. So we're not going to be able to get a Hamiltonian cycle matching these edge pairs. Of course, there's other Hamiltonian cycles out there, right? So One thing we might want to justify is just, we said this in the previous video, but just, let's pretend that I'm going to break all the rules and let's say I came up with a Hamiltonian cycle. Because what I should really hope is that if I don't have a solution here, I shouldn't have a solution to this problem. If I had a Hamiltonian cycle like this, well, it doesn't accurately represent the problem because I have this edge pair be between edges 3 and 6. And I didn't use either of those. So this Hamiltonian cycle, even though it's a Hamiltonian cycle, it doesn't match my edge pair condition. Since we carefully allotted how this problem turns into a Hamiltonian cycle problem, we set this up so that if I have a Hamiltonian cycle, I'm repeating myself. I think it's fine. I think there's enough good content in those first few minutes. I'll just leave it there. So there we go. There's some evidence that if I don't have a solution to this Hamiltonian cycle problem, then I also don't have a solution to the 0-1 equation problem. And that's just because we were very careful in taking every single condition on the 0-1 equations, basically saying that I'm only allowed to use A has to be 0 or 1, and depending on which ones I set to 0 and 1, that means which columns I'm using in my sum. And we very carefully set that up so that if I don't have a solution here, that means that I must not have had a solution here to begin with.